Hello. Today is the 24th, Thursday. I had been going through some of your homeostasis worksheets and I've been addressing a couple of questions, and I realized that we need to go a little bit deeper into homeostasis. So I was looking for an animation, something that you could do, and what I found was something on Flash Player that I know that a lot of you won't be able to do, the Adobe um, connection. So I decided to make a video of it. So I'm going to play through it and talk at the same time. So this will be kind of a lecture versus video, whatever. So here we go.
Maintenance of the stability and equilibrium of the body's internal environment, from cells to systems, is called homeostasis. Homeostasis is a dynamic condition. The continuous interplay and constant adjustments of the body's regulatory processes and systems function to keep our bodies in balance. Changes in the internal environment can vary from minor to significant and are categorized as normal limits, disruptions caused by temporary stresses, disruptions requiring medical intervention, and severe disruptions that cannot be restored and are incompatible with life. The equilibrium point can change over a narrow range, the body's normal limits, and continue to sustain relatively good health. For example, while a body temperature of 98.6 degrees Fahrenheit may be optimal, a change to 99.2 degrees would be within normal limits. Normal limits serve as the basis for medical testing. Medical test results are compared to these normal limit values to help determine if homeostasis has been disrupted. Stresses from both external and internal environments can move body conditions away from normal limits. When stress on homeostasis is mild and temporary, the responses of the body cells quickly restore balance in the internal environment. Shivering is one of the body's responses to adjust body temperature back to normal ranges. When a stimulus or stress is more severe or constant, such as a high fever or chronically high blood pressure, an underlying disease or disorder may be indicated. Medical treatment and intervention is often needed to return the body to homeostasis. If disruptions are extreme, the regulation of homeostasis may fail and death occurs. Communication between the body's cells, tissues, and organ systems is crucial to effectively regulate and maintain homeostasis. Two body systems, nervous and endocrine, play particularly important roles in fulfilling these major tasks. The nervous system provides a framework for sensory, integrative, and motor functions. The endocrine system secretes powerful chemicals called hormones that regulate body functions.
Oh, it says click on the body to continue. So here we go.
A feedback system is a cycle that constantly monitors, evaluates, and adjusts the status of the internal environment of the body. A cycle is triggered by a stimulus that alters a normal homeostatic state, called a controlled condition. All feedback loops have three main components: a receptor, control center, and effector that communicate with one another to maintain controlled conditions. Most receptors are sensory nerve cells that monitor and communicate changes in the status of a controlled condition.
So that's going from your to your spinal cord. That's what this is. So this would be your nerves going to the spinal cord.
The hypothalamus is an important integrating center for both nervous and hormonal regulatory processes. The range of values for a controlled condition, such as body temperature, is set in the control center. The input from receptors is evaluated and compared to norms by the control center. A plan of action for response to the altered condition is formed in the control center as well. Regulatory commands to affect the change in status of the controlled condition are communicated either in the form of electrical nerve impulses or secreted hormones, or both.
I don't know where to go. I did click on a hormone. There we go.
Effectors are the cells of any body structure that receives output from the control center. Effectors produce a response that
If I go
adjusts
way
the
over
altered
here.
controlled condition.
So clicking on the effector. Oh, they wanted us to click on one of these effectors. So these are the organs that the target cells are going to.
Most of the body's systems use negative feedback systems to maintain homeostasis. They are called negative because they reverse the altered controlled condition. For example, if a stimulus causes a rise in blood pressure, the feedback cycle will reverse this and lower the blood pressure. When the controlled condition is returned to its normal state by the feedback system, homeostasis is attained. Positive feedback systems are fewer in number because they reinforce an altered control condition that doesn't happen very often. Labor and childbirth is an example. A positive feedback loop can only be stopped by a mechanism from outside of the system, such as the birth of the baby.
So what I wanted to say about that is negative feedback is going to reverse the problem. So it's going to take away from the problem. Positive feedback is going to add to the problem. So stretch receptors in the uterus are going to trigger contractions, and those contractions trigger stretching, and it keeps going back and over and over and over again. It's not until the baby is out that the stretch is no longer there. And so that's the example of positive feedback. I think the rest of this, these links weren't working, so I'm going to show you one more. I'm going to show you a simplified Amoeba Sisters video to show you how the feedback loops work. So that will be next.